Okay, hi everybody. Here we are in Coterminal angles video 2 here, determining the exact values of the primary trig ratios for very large angles here. They could be positive, they could be negative, but they all have sine, cosine, and tangent values. And those sine and cosine and tangent values are the same for every coterminal angle. So for example here, number 10 and number 12, on page 448 to 449, you would just use your calculator to find the sine, cosine, and tangent values for those particular functions. Sorry, for those particular angles in standard position. So for instance, the sine of negative 781 degrees. You just punch in negative 781 sine, and you'll get a decimal to 3 decimal places. Now, number 11 asks for exact values of primary trig ratios. So that's an indicator that you're going to have to use the special angles triangles, and I've drawn them up here for you to help you come up with your trig ratios. You also have it at the bottom of the web page that I have. There's a handout. You can click on that and keep that handy as well when you're doing your homework. Now, for instance, theta is 1,740 degrees. We want to find the exact sine, cosine, and tangent ratios for that. So let's start with this. We're going to make a little sketch, make it visual. 0 degrees. If I go all the way around, that's 360. Again, 720. Again, 1,080. Again, 1,440. If I go all the way around again, I go to 1,800 degrees. That's too far. I'm going to have to back up. To get to 1,740, I'm going to have to back up 60 degrees. So what would it look like? Here would be our terminal arm with the point P. So 1, 2, 3, 4, 5. Goes all the way around there. And that's how we would indicate 1,740 degrees. Now, let's find point P. We know that we'll bring a line up from point P to the x-axis and create ourselves a little reference triangle here. This is just a triangle that we can use to find some measures. The reference angle is 60 degrees. 60 degrees. 1,800 minus 1,740 is 60. And if that's 90, that makes this a 30-degree angle. A 30, 60, 90 triangle, just like this one. It's like we've taken this triangle, rotated it, and placed it here. And if that was the case, we could find that this side length is the same length as this side length, a total of 1 unit. And that this dotted red line to point P is the same length as this side length, or root 3 units long. And the hypotenuse, or the terminal arm, is the same length as the hypotenuse here, 2 units long. So that's how we're going to use our special angle triangle. Point P, this point right here on the terminal arm, we would have had to go from the origin, travel 1 unit to the right, x coordinate is 1, and root 3 units down, negative root 3. That'll be our point. And the value of r is 2. We got all the information we need here to find the sine, cosine, and tangent values. The sine, that's y over r, negative root 3 over 2. The cosine, that's x over r, 1/2. And the tangent value, that's y over x. Negative root 3 over 1 would just be negative root 3. We've just come up with the exact sine, cosine, and tangent values for 1,740 degrees without using a calculator. You're going to find, you can use your calculator to check it. The principal angle from here to here would have been 300 degrees. If you were to find the sine, cosine, and tangent values for 300 degrees, they'll be the exact same values for the sine, cosine, and tangent values for 1,740 degrees. They're coterminal. They would both have the terminal arm in the same spot, and their little reference triangle would be exactly the same. This will help you for homework, page 448 to 449, number 10, 11 for sure, and 12. So we'll move on here. I want to emphasize again, we touched on it earlier in the previous video, but right here, coterminal angles share the same primary trig ratios. Why? They share the exact same sine, cosine, and tangent values. Well, how is that possible? That's because point P and the length of R are exactly the same. So for instance, I've diagrammed 127 degrees. The terminal arm falls here. It passes through point -3 and 4, and the length of R is 5. Well, -223 degrees, if I diagram that one, I'll rotate backwards. The terminal arm falls in the same spot. Still passes through -3 and 4, and the terminal arm is 5 units long. Exact same triangle in the exact same location. The reference angle for both of them from here to here is 53 degrees, 53 degrees. So we have the exact same little reference triangle we can use. And once again, you'll find the sine. That's y over r, 4 over 5. And is it the same over here? Yeah, 4 over 5. The cosine, that's x over r, -3 over 5. And that'll be the same here, -3 over 5. And the tangent value, 4 over -3. And it's the same here, 4 over -3, y over x. The sine, cosine, and tangent values for 127 degrees and -233 degrees and any other coterminal angle will be the same because they pass through the same points on the grid. They have the same reference angle and they use the same reference triangle. All right, we'll take a look at an example in a moment. Okay, so here's an example, page 450, number 13. We're looking for some angle in standard position that's between 360 degrees and 720 degrees. That has a sine value of 1/2, a cosine ratio of √3 over 2, and a tangent ratio of 1 over √3. Now you may recognize those are the sine, cosine, and tangent values for an angle in standard position. But we can diagram this, make it visual. Sine, that gives us the y coordinate point P. Y coordinate P got to be 1. The cosine value, that the x coordinate point P has to be √3. So we'll put it here. R is equal to 2. Now, where would this point be located? We'd have to travel √3 units to the right and 1 unit up. So right about there, and I'll draw a terminal arm, point P. Our angle, our primary angle, our reference angle is going to be right there. If I drop a line to here, I know that this side length is √3, this side length is 1, and the terminal arm is 2 units long. Wait a second, this triangle, it's like we've taken this triangle and rotated it. That would be, for this angle, that's the adjacent side. That angle, that's adjacent side. 30 degrees here, so this must be 30 degrees. We know that the reference angle is 30 degrees, and then for this particular case, the principal angle is 30 degrees. Now, one problem is that our angle, it doesn't fit within this domain between 360 and 720 degrees. So we got to come up with a coterminal angle to 30 degrees, but that falls between 360 and 720. So I traveled 30 degrees to get to here. If I go all the way around again, my angle in standard position would be the principal angle, 30 degrees, plus another 360 degrees, which is 390 degrees. Does that fall within the domain? Yes, it does. If you were to take your calculator and find the sine, cosine, and tangent ratios for 390 degrees, they're going to give you these numbers back as a decimal. Okay, so here's another example. Number 14a. Theta represents an angle, or angles in standard position, between -360 degrees and +360 degrees. So the domain of the possible angles that share the same sine, cosine, and tangent values are larger. There's going to be more than one answer here. The sine value is 1 over root 5. The cosine is negative 2 over root 5. And the tangent is negative 1/2. Well, the sine and the cosine tangent, they tell us something about point P. The y-coordinate is 1, and the x-coordinate is negative 2. And r is equal to root 5. R is always positive, we know that. So where do we find this angle in standard position? Point P is at negative 2 and 1. So from here I'll go 2 units to the left and 1. Negative 2 and 1. And I'll draw my angle in standard position. There's our angle in standard position. How are we going to find that? Let's find our reference angle first. Our reference angle, okay, we know that that's a total of 2 units, that's a total of 1 unit, and that's a total of root 5 units. We got ourselves a little reference triangle we can work with to find the reference angle. And the reference angle worked out to 27 degrees. So if we've got 27 degrees here, well then what's our principal angle? From here to here. That would be 180, take away 27. Our principal angle from here to here would be 153 degrees. Hey, that falls within our range here, or our domain. That's between negative 360 degrees and positive 360 degrees, so that can be one of our answers, but it may not be the only answer. We want to find angles that are coterminal with the principal angle, coterminal with 153 degrees that fall within the domain here. So let's add it. Let's add 360 degrees. Go all the way around and get the terminal in the same place. That would give us 513 degrees. It's not going to work. It's too big. It doesn't fall within our domain here. What if I subtract 360 degrees? What if I go 153 degrees, rotate backwards, take away 360 degrees? We would get negative 207 degrees. That does fall within our category. That's between negative 360 degrees and positive 360 degrees. So if you'll find that the sine, cosine, and tangent values for 153 degrees and negative 207 degrees are exactly the same. It satisfies this information, and both of them are found within our domain between negative 360 and positive 360 degrees.